You type git push, you hit enter, a few seconds later your code is on GitHub. But between those two events something genuinely fascinating happens. Your computer negotiates with the remote server, files get hashed, packed and shipped, refs get updated, hooks fire. Most developers do this 20 times a day and have no idea what's actually happening behind the scene. Today that's ends. Let's break down everything that happens when you run git push. First, you need to understand what Git actually stores. Most devs think of Git as saving files. It's not, it's a content-addressed object database. Every file you commit gets hashed. Every directory structure gets hashed. Every commit itself is a hash. Three types of objects: blobs for files, trees for directories, commits for snapshots, and they are all referenced but they are hashes. When you make a commit, Git creates these objects in a folder called .git/objects. Your commit history is just a linked list of commit objects, each pointing to its parent. Now we have the foundation. Let's push. When you type git push, the first thing Git does is figure out what to send. Your local branch, let's say main, points to a specific commit. The remote also has a main. The question Git asks is, what commits exist on my main that are not on the remote's main? Git looks at its commit graph, walks backwards from your local main and figures out which commits the remote is missing. But it doesn't just send the commits. It also needs to send the trees and blobs those commits reference, the full picture. Now the network part starts. Git connects to the remote, usually over SSH or HTTPS. It says, hey, here are my refs, what do you have? The remote responds with its refs. Now both sides know who has what. This is called the negotiation phase. It prevents Git from sending objects the remote already has. If your branch is just one commit ahead of origin, Git only ships that one commit's data, not your entire repository. Git takes all the objects it needs to send and bundle them into a single compressed file called a pack file. Inside the pack file, deltas, efficient diffs between similar objects. So if you changed 3 lines in a 1000-line file, Git ships those 3 lines, not the whole file again. This is why pushing 50 commits doesn't take 50 times longer than pushing one. The pack file is brutally efficient. The pack file flies across the internet, through SSH or HTTPS, compressed, encrypted and validated. On the other side, the remote server receives the bytes, reassembles the pack file and verifies every object's hash matches its content. If even one byte was corrupted in transit, well, the hashes don't match. The push fails. Git is paranoid about data integrity, and that's a feature, not a bug. Now comes the moment of truth. The remote has all your new objects. It needs to update its branch ref to point to your new commit. Before it does that, it checks, is this update a fast forward? Meaning, is the remote's current commit an accessor of the new commit? If yes, the ref updates. Push succeeds. You see main and smiley face. If no, if someone else pushed something while you were working, the remote rejects the push. You get the dreaded not fast forward error. You would need to pull, merge and try again. Or you could force push, which leads to the next section. A force push tells the remote, I don't care if this isn't fast forward, update the ref anyway. And this is dangerous. If a teammate had pushed commits to that branch while you were working, force pushing override their commits. They are not deleted from the universe, of course. They still exist in Git's object database, but the branch no longer points to them. Anyone who pulled those commits now has a deviant history. This is why git push force is one of the most respected and feared commands in software. Use force-with-lease instead. It checks the remote's current state before overriding. Also, before the ref updates, hooks fire. Pre-receive hooks can validate the push, reject it for policy reasons, run tests, scan for secrets. Post-receive hooks can trigger deployments, notifications, or anything else. This is how GitHub Actions and CI/CD pipelines wire into your push. So that's git push in full. Local commit graph analysis, network negotiation, pack file creation, compressed transfer, hash verification, ref update, hook execution, all in a few seconds between your keystroke and your code appearing in GitHub. Now, when you see a non-fast forward or rejected, you'll know exactly what just happened and why force-with-lease is your friend. If this helped, hit subscribe. Next Tuesday, I'm explaining how Docker containers actually work. See you there.